My name is Anna Patrick, and I am a physician scientist in the Division of Pediatric Rheumatology at Vanderbilt University Medical Center. Thank you for having me to speak to the Imprint group today. My project that I'm presenting is the development and validation of a multi-institutional electronic juvenile idiopathic arthritis phenotype. First, we need to talk a little bit about juvenile idiopathic arthritis, or JIA. This is the most common autoimmune arthritis in children. It is diagnosed clinically by 3 criteria. The symptoms must begin before the age of 16, the arthritis must be in 1 or more joints for at least 6 weeks, and this is a diagnosis of exclusion, so the arthritis cannot be due to malignancy, infection, or another source. Here, I'm showing 2 pictures of children with JIA, which highlights the wide range of disease severity. On the right is a graph with patient number on the y-axis and age at diagnosis on the x-axis. Girls are the purple bars and boys are the blue bars. You can see that there is a peak age of onset before 5 years old. In diseases with an early age of onset like JIA, it's suggested there's a higher genetic contribution to disease. JIA is very complicated though. On the left, I am showing the clinically defined subtypes of JIA. Patients have a range of disease severity from mild to severe, varying chronicity, and varying responses to therapeutics. On the right, I am showing that we have targeted, powerful, numerous, and expensive therapeutics to treat JIA. We have clinically defined subtypes and clinically defined therapeutics, but with our current knowledge, we do not know the optimal therapeutic for an individual patient. So there is a critical need for precision therapeutics in JIA to fill this knowledge gap. And this means that we really need to learn more about JIA phenotyping and how JIA patients respond to medicines. So there are some important things to know about studying JIA. First, this is an uncommon disease. Second, we have multiple subtypes. We also have potential bias in all of our clinical registries. And we really need to be able to study patients across multiple sites. So there's an opportunity. This is to use electronic health records, which are widely used and contain extensive clinical data. Now, one of our challenges is to ascertain a true cohort of JIA patients using claims and EHR data. So in this study, we aim to develop a computable JIA phenotype to identify patients with JIA using large databases with multi-site validation and replication. So the development of algorithms to identify JIA patients started in the EHR at Vanderbilt. On the left, you can see the general process by which we used algorithms to identify potential JIA cases and then to validate these algorithms. On the right, I'm just highlighting that multiple different ICD codes are associated with JIA, and this indicates how accurate identification of subjects can be very complicated. So we sought to build a computable algorithm at VUMC so that we could take our algorithm and also apply it at other institutes. We decided to use JIA-associated ICD codes and ICD code counts. We modified the algorithm so that we only counted 1 code per day, and we also counted each code as 1, meaning that we didn't require the same code to be repeated of all those different codes you just saw. We added an age requirement for the first JIA-associated ICD code. We also used exclusion criteria, and these criteria used ICD codes to remove cases of systemic lupus erythematosus, dermatomyositis, and polymyositis. And we chose to avoid using keywords. With the help of the VUMC phenotyping core, we have been making these algorithms portable and introducing the changes discussed on the prior slide. On the left y-axis is positive predictive value, and the right y-axis is JIA cases identified. Across the x-axis is the number of JIA ICD code counts required as a minimum. We found that increasing the number of JIA ICD codes increased the PPV while decreasing the total number of JIA identified. We added an age constraint for the first appearance of a JIA-associated ICD code, with the code needing to appear at an age of 20 or younger. We found that addition of an age constraint significantly improved the PPV and also decreased the total number of JIA identified. The next step was to take these algorithms and apply it across multiple sites. So we used our friends within the Imprint network, and we had sites at Vanderbilt, Nationwide Children's, and at Riley's. And the people who participated and were essential in this process are listed below each site. The people whose names are listed in black are bioinformatics personnel, and the people who are listed in blue are pediatric rheumatology providers. So we then applied the algorithms at each of these three institutions. In the algorithms, we used JIA-associated ICD codes and the ICD code counts. We applied the exclusion criteria in each algorithm, and we had an age requirement for the first JIA-associated ICD code. The pediatric rheumatology healthcare providers manually reviewed a selection of charts to validate the JIA diagnoses against their EHR. The results are shown here. So there are 3 sites, with the last being all sites combined. So what we found was 8,589 subjects that had JIA diagnostic codes. 7,800 of one of these subjects had diagnostic codes and also met exclusion criteria. We had 262 charts that underwent manual chart review with a PPV of 0.72. The trends were consistent across all sites, whereby increasing the number of ICD code counts or visits resulted in a decrease in the total patients identified. However, the PPV increased. So here you see the algorithm identification of JIA across all sites. You can see that across the x-axis, the JIA code count, as this increased, we see an increase in the PPV with a decrease in the total JIA identified. The dotted line is representing a PPV of 0.95, which you can see reflects a JIA code count of 4. So we developed and reproduced a computable phenotype to identify children with JIA across multiple institutions. We are planning to compare demographics and patient characteristics across sites. Importantly, these algorithms can be utilized in collaborative research networks to more accurately study outcomes. To thank the teams at Vanderbilt, Nationwide, Riley, and the Imprint Network for their support in this project and for the exciting progress that we have made, with great future progress soon to come. Thank you.